Good day, students. Today, I want to solve problem that involve tension under equilibrium of forces. What you need to do is to analyze your diagram. We notice that we have two tension, a wooden frame weighing 2 Newton. You can see this is the wooden frame, weighing 2 Newton is hung on a nail using 2 ropes. There's a nail here hung on a nail using 2 ropes as shown below. Find the tension in the ropes. Okay, you notice that we need to resolve these forces, this tension into sideways direction, to be vertical to the downward force, which is 2 Newton. But you say that you have to put your dotted line here. The angle, the line that is opposite to this angle is the opposite. Stand opposite. Use dotted line to show it. Opposite. While the longest line is hypotenuse, while this is adjacent. The same thing, you have the adjacent to this line, and this is hypotenuse. Okay, it's like when you're having to, just take it in a way that you understand it. This is angle 60 degree. This is the hypotenuse, and this is opposite, angle 90 degree. We are going to apply socatura so that you can get our tension. It's the same thing with the other side. We have the socatura. Okay, now we have this as the tension. I want to resolve it to the vertical direction, which is the adjacent. This is the adjacent. And what with the adjacent? Please, for better understanding, you can still do it like this so that it will be in this form. You have it like this. You have 60 degree. You have the opposite. You have the adjacent. You have the tension, which is the hypotenuse. Let it be in this form so that we can relate it directly to the diagram. So that we need to resolve this line, this tension line. We need to resolve it to the vertical side, which is the adjacent. We are going to use socatura. That means that it involves adjacent and hypotenuse. Now, we now use adjacent, which is car. Okay, we now have cos theta equals adjacent. Okay, since I put solution here, let's continue from here. Cos theta equals, what is it? Adjacent over hypotenuse. In that case, what's our theta? 60. Cos 60 degree equals, what's our adjacent? That what we need? Adjacent over hypotenuse is taken as tension. You cross multiply this over 1. You have adjacent equals 1 times cos 60 degree. T times cos 60 degree, which is T cos 60 degree for the adjacent. Now let's see the other side. Is still having the same diagram, but it will be of this, facing this side. You can see it, 60 degree is still opposite. Yeah, and we have adjacent. Okay, we still follow cos theta. This is our tension, hypotenuse. So you have cos 60 for the other side equals adjacent over tension, which is the hypotenuse. Or we cross multiply. You have adjacent equals tension times cos 60 degree times cos 60 degree. From there you have T cos 60 degree. See that we have two upward forces that are equal, they are the same, and you have the sum of the upward forces equal to sum of the downward forces, and the algebraic sum, we have to look for the algebraic sum of the tension so that we now equate it to 0 to fulfill the conditions of the equilibrium. Now the upward forces, you have to know that summation of F equals to 0, summation of Fy equals to 0. As now following that condition, you have upward force. How many upward forces do we have? 2. We have T cos 60 degree plus the second one T cos 60 degree. The down one, when you are dealing with graph, upward force is positive, negative, it's coming down, minus, introduce minus because it's moving towards the negative side. This is negative, so it is positive and this negative. It's moving towards the negative side. Minus 2 equals to 0. That is summation of forces toward the y-axis is equal to 0. Now you have T cos theta plus T cos 60 plus T cos, you have 2T cos 60 degree equals to, take minus 2 to the other side, 0 plus 2. You now have 2T cos 60 degree equals to 2, divide both sides by 2, divided by 2, 2 cancel 2. You now have T cos 60 degree equals to 1. You now have T cos 60 degree equals to 1, divide both sides by cos 60 degree, cancel each other. You have tension to be equal to 1 over cos 60 degree is half. That's 1 divided by 1. This 1 stand alone, divided by 1 half, which is 1 divided by 1 times. When you are changing the division to multiplication, to the denominator will go to the numerator, while the numerator will come down, becomes 2 over 1, which is 1 times 2, that's 2 over 1, which is equal to 2. Therefore, 2 Newton, the tension is in Newton. We have to find the tension in the ropes. Therefore, the tension in the rope, tension T in the rope equals to 2 Newton. This is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.